Hey, hello and welcome to my project logs. Today is the 20th of May 2011. My name is Mbowe. Yeah, so here is everything. So we've already defended our project and just here to show you how everything works and how everything fits in together. As you can see, it's like wires all over the place, but it's okay. I'll explain and tell you what everything is. We start off with the development board, which is this one. As you can see, it's using the propeller chip, and this is where the propeller connector would go. The prop plug, and it has one EEPROM connected. Okay, the main reason why this one is there is I wanted to connect two EEPROMs so that one would act as the backup or data store, and all the program will be stored on this one, which is going to be the boot EEPROM. You can see we have some status lights here, which are the status indicators, so which are there, and then they are connected from pin 16 to 23. Okay, on this side we have two push buttons which are used for inputs, okay, to either start something or stop or increase or decrease anything that the program wants. And then they are connected hardwires to pin 8 and 9. Don't worry about the wires, I will talk about the wires a bit. Okay, over here we have our sources of connection. So we have three sources of connection, sources of power, sorry, to the board. We can either use the breadboard connection here, or we can use the 9 volts which we can supply here, or my favorite really is using the USB, this one. So all that I would do is take my USB connector, which is this one, as you can see, and I connect it to my laptop, or any sort of USB. I mean, anywhere you can tap USB from. Some other places have got USB ports that you can use to charge, and then connect it there, and then straight away just connect it in there. So once you do that, you can then power up, and then you would be able to use the board with the USB. That's the switch for powering on and off. So once it's connected, power it on there, and voila, there you have it. So that is taking power from the laptop. Okay, that's the board. The power supply is here, so it has its own regulators. So there are two. This one is the 5 volts regulator, and then this one is the 3.3 volts regulator. 3.3 is for the chip, the propeller chip, and any of the sensors that needs 3.3, like the compress will connect it to 3.3 volts. Okay, the 5 volts regulator takes in supply from either the battery, which is this one, or it takes in supply from the external connection. But since the USB already gives a regulated 5 volts, so what we've done is we've bypassed it and just connected straight away to the 3.3 volts. Okay, so now this board can supply voltages as well. So in here you have the 3.3 voltage output here, okay, which is this one, the bottom one here. Then here you have the 5 volts rail, which is like you can use to connect anything that needs 5 volts. And over here we have the 9 volts rail, which you can use to connect or give power to anything that needs 9 volts. The reset button, it's somewhere hiding here, as you can see. That's the one there. Okay, so we have our power supply here, and then we have our propeller there that we can use to develop. Okay, so that's the board. Let me switch this off for now and then move the cable away so we can see what we have. Alright, so from the board now we move on to the sensors. Okay, so the sensors are all connected to the first 8 pins, which is from pin 0 to 7. So what we basically have is these 5 sensors, right? So we start off with the first one, which is the GPS. So that's our GPS module. Okay, it's the one with the microcontroller there. So it only has one IO pin which connects to one of the pins there. That one of the IO pins there, which is the output pin. It's called serial IO, serial input output. Okay, then we move on to these two bodies. I think recognize what they are. They are like infrared sensors for object detection. We have two of them. This one is marked F, meaning that it will be used for the front, and then this other one is marked B, which means that it will be used for the bottom. Okay, so from the infrared we then move on to the tri-axis, which is the one we have here. As can see the traction accelerometer. What we're using it for is for tilt detection. So when the aircraft or the helicopter is tilted in any of the x and y direction, it should be able to detect that. We're not using the z direction for that, the z tilt, because I don't know, if we tilt it in a z, it doesn't respond until it's fully vertical, which we're not exactly sure why. But then we're using, instead of that one, now we're using the digital compass. So digital compass is what would regulate or maintain a heading. So when there's a deviation from the desired heading to maybe the reading from the sensor, it should try and actuate the server, or we'll come to that one in a minute. Okay, so all of them are connected via this thick wire, as you see, and it goes all the way to the microcontroller IO pins. Okay, now looking at this red one, okay, here we have a loop here, okay, and then finally it goes on to the aircraft, and this is the helicopter. Okay, so it's an eraser 250 for sports, 3D ones that can do a lot of stuff, even upside down, fly and all that. So it basically has 4 sensors, 2 on the side, 1 for the elevation, called elevator, and then you have the rudder. Now the rudder normally connects by the and this one, the gyro, but then when we tried the gyro, it wasn't working for us, so we bypassed it and connected it directly. Have you noticed that there's something missing? Yeah, the receiver is not there. So basically we've removed the receiver, and that's where it should have been, and what we've done is we've connected this board there, right? Now this board, what it does is it's like a concentration point for all the servers, okay, and then the BC, or the connector from the ESC, would connect to that and then distribute power or power up all the servers. Good. That is what we want. That's the ESC right there, you can see, and then yeah, this thing is the brushless motor. Okay, power goes in from this pin here. Okay, so these two, these two connect, this connection will give us power. All right, so this board we we soldered it, we did it so as to just distribute the power, and then be a concentration point for our signal as well, because we have a signal wire, which is this one, which connects to the helicopter, so that if you want to control any of those servers, we'll just need to pass it through here, and then via this cable. So that's what we have so far. So as you can see, the helicopter is a bit too small for this to fit in. Okay, but then that's the main reason why we put this long wire here, so that we can have it separate and then let it all go through it. We're still checking. Then afterwards, this would go in somewhere, anywhere it will go in, and then this will be like the autopilot. Then the sensors, for example, the front one will just go somewhere there in the front. Of course, we will punch some holes in the canopy so that it will show. Then the bottom one will then go somewhere at the back. Or the digital compass will have to stay away from the ESC for because of the electromagnetic and then stay the electromagnetic field, and then stay somewhere out. It's very light, so it doesn't weigh much, so it won't affect it at all. So we put that there. The GPS as well might need to stay off, so maybe we might just put it where the battery was, and or put it somewhere else. But then for now, none of this stuff will be going on the board, right? So what we basically did was we needed something to simulate the platform of the helicopter, right? So what we created afterwards was we created this board. Now this thing, it's just a simple normal board with some legs, and these legs are made from pins, yeah, paper pins, you see. And then this would like house the sensors, and it will act as, let's say, the platform for the helicopter. So we will be using this to simulate the sensors being on the helicopter. So basically we have just we have like let's say placeholders where all the sensors would go, okay, and then once we've done that, then if we are maybe demonstrating takeoff, we will then be lifting this up so that it would demonstrate, and then checking the reading for the IR. If we are demonstrating, let's say, tilting, okay, how it reacts to turbulence, for example, we'll just be shaking this or shifting this, and then we will see how it responds. So we will do that in a minute, but for now it's just an intro. So the next video that we will do would be testing the servers and see whether they work. Then from there we have to test all the sensors, so we will test the sensors and also see where whether they work. Then from the sensors we will then move on to test the ESC, because the ESC is quite important. Then see whether we can control that. Then from the ESC, yeah, then we can say, okay, now can we test it taking off, because you can read from our sensors, we can actuate our servers and we can start our engine. Yeah, so that will be the next one to do. And then from taking off we then say, okay, now how about stabilizing? If it's going into a windy environment, how does it actually maintain its heading at the same time stabilize itself? So that will come next. Then from then we can say, okay, now how do we actually move forward, right? By pushing up and pushing down. That one is a bit easy. You just control the elevator, which will demonstrate. And then from there we then ask ourselves, okay, now how do we, after pushing up pushing down, detect object? Because once it's moving, by controlling the pitch, right, it needs to know whether it's heading towards a mountain or not, right? So how do we do that? By using, of course, the front to see, check for objects in front, the front IR, on using the bottom one to check for objects underneath, so that if it's going up a mountain, it will know that, okay, I'm a bit too close to a mountain, so what should I do? Should I increase power to attain lift or not? So all that stuff it would do, and it will demonstrate it for you. And then finally, how is it going to land? Because if it's going to be an autopilot, it needs to know all of this stuff, right, to then demonstrate how it's going to land. And then one last one to do, which is using the compass. How will it actually get the heading to its destination? With that, so using the GPS, not the compass, but it will also need a compass to actually control its direction. So with the GPS we can get our current location, right? So all that you need to tell it is, okay, I want you to go to this place. Okay, so it will then be able to compute its heading from its current location to the input, which will also demonstrate to you. Okay, so we can end it here for now, and then afterwards we will then start off with the actuating the server test. Okay, see you soon. Bye.